Hi guys, this is the 2.1 notes. So this is our second unit or second topic. The second topic deals with quadratics. The first three sections are very, very important, especially if you're going into pre-calculus next year. So now what is a quadratic equation? So when a quadratic function is written in vertex form, you can easily identify the vertex. Okay, so right, we know we're used to right g of x when we did transformations. Remember of parent functions is a times f of x minus h plus k. Well, when we have a quadratic, it's always an x squared function, right? So right, quadratics are x squared. Okay, so right, we have an a in the front again still, which if it's negative, it reflects across the x-axis, and if it's greater than so this is when it's negative, right? When a is greater than 1, then it's a vertical stretch, and then when a is between 0 and 1, it's a compression. Okay. Now, h tells us our h tells us our horizontal translation, so left or right, and then k tells us up or down. Right. Now, one thing, right? Our quadratics usually look like this. Okay, we call this concave up, or meaning it opens up. Okay, you'll hear me say opens up when a is positive. Okay. Now, when a is negative, we have a reflection over the x-axis, so it's going to be an upside down U shape, right? Which we call concave down or opens down. So that's when a is negative, and when a is positive, it's just a normal U-looking shape. All right, and now our vertex, what that comes from. So our vertex, this is very important. H comma K. So whatever your H is, remember you're not including that negative sign, right? Whatever your H is your X value of your vertex, and whatever your K is your Y, because they change where the original x squared function goes. So vertex is h comma k. Okay, so now we're going to do key features of a quadratic, right? We've done key features before. So what we'll do is we'll start off by labeling our A and our H and our K, right? So our A is equal to 2, meaning we have a vertical stretch. Okay, and then the factors with a factor of 2. Right, we have an H. Our H is positive 3, and then our K is positive 4. So we move right 3. K is positive 4, so we're going up 4. Okay. It gives you the graph of this, so you can see, right? It shifted to the right 3 and then up 4. And then we had a vertical stretch, so instead of it being 1, our next point we can see, it's going to be 1, 2 away from our new vertex, right? And so again, this is our vertex. So we can label this vertex h comma k, right? Which means our vertex, h is 3, k is 4, so 3, 4, and you can see it is at 0.34. Right? And then, right, this dotted line is the x value of our vertex, right? So that's our axis of symmetry, remember. Which is x equals 3, right? It's our x value of our vertex. It's where our two sides of our function are essentially reflecting each over that line, right? And you can see they're like a mirror image on each side of that line. All right. A couple other things is the domain. Oops. Our domain, right? Remember our x values, right? It goes all the way. It's going to keep going to negative infinity and infinity. So our domain is negative infinity to infinity, or all real numbers. Our range, our lowest point is 4, and it includes it, right, for our y values. And it goes all the way up to infinity, so 4 to infinity. Our last thing I want to introduce, because we'll see this, is we either are going to have a max y value or a minimum y value, right? So max, highest y value, minimum lowest y value. So if we look at the max y value, our highest point, we don't have a finished point. So we would say there are none, okay? Right, no max, right? Because there's no, it goes to infinity. We do have a lowest point, right? Y equals 4 is our lowest point, right? So our minimum is y equals 4. Right, those are pretty easy. Now, this question I'd like you to try on your own. All right, we can just kind of start it. So our a is -1. So remember that's a reflection over the x. And then we have h of -4 because it's x minus -4 to get x plus 4 there. And then a k of -5. Okay, so what I want you to label is I want you to label the vertex. I want you to label the axis of symmetry, the minimum, maximum. Remember, with quadratics, most of the time you only have a min or a max. And then domain and range. So I want you to pause this now and try and complete this, and then we'll go through the solutions together. All right, so hopefully you pause it. We can draw our original x function. So this goes by 20, so 10, yeah, something like this. I don't know. Like this is something like our x squared. It doesn't have to be perfect because we're writing it in. Now, our vertex, it's h comma k, so -4, -5. Okay, so negative. So I think these go by 4s. Yep. 4, 8, 12. Yeah, they go by 4. So -4 and then -5 would be like right here. And remember, a is -1, so it should be concave down, okay, or opens down. So our U shape's going to go down. Our next point could be like 1, 1. What did I just do? All right, so for this case, let's just kind of just briefly draw it. If you wanted to find points, right, you could plug in 0 for y and 0 for x, right, which would be what, negative 16 minus 5, negative 21. So that's where it should cross, is actually negative 21. That'd be our y-intercept. 0, negative 21, right? And our axis of symmetry, right, should be going through here. Right, and now you think about it. So this is 4-way, so it'd be 4-way on this side, right? Because it's a reflection. So there's our function. All right, and this would be negative 8, negative 21. And there's our function. Axis symmetry we filled in is x equals negative 4. Our minimum, we don't have one because it goes all the way down to negative infinity. Our max value for y is negative 5. Right, that's where the vertex is. And then our domain goes all the way to from negative infinity to infinity. You'll notice on these functions, almost every time the domain is going to be negative infinity to infinity because you can have every x value on them. The range is what changes. This one starts at negative 5 and then goes down all the way to negative infinity. So it does not start at negative 5. It starts at negative infinity and goes to negative 5. Right, and it includes negative 5. All right. All right, so that was graphing and finding the key features when a quadratic is in vertex form. Now what we're going to do is we're going to find the equation. So we're going to, it says, what is the equation written in vertex form of a parabola with a vertex 3, 4 and a line that passes through 1, 2? So we're going to be given the vertex, and then we're giving a point on the parabola or that quadratic function, right? So it goes step by step. I've kind of labeled them for you. It says put vertex in the vertex form of a parabola. Okay, so remember we have a times x minus h squared plus k. Right. So, right, we have f of x is equal to a, because we do not know what a is, x, our h is 3, and our k is equal to 4. So we have x minus h, or x minus 3, squared, plus 4. Now we want to substitute in points for x and f of x, right? So we're going to substitute 1 in for x, and for f of x, right, we're going to act it as our y, so it's going to be 2. So you'll see me substitute in 2. We need to solve for a, so it stays as a. And then for x, we're substituting in 1, and then plus 4. Now, right, we get 2 equals, oh, it has me solve it up here. Okay, so 2 equals a times 1 minus 3 is negative 2 squared plus 4, which equals 4a, right? 2 equals 4a plus 4, minus 4 to the other side, right? We get negative 2 equals 4a. Therefore, a is equal to, divide both by 4, you get negative 2 over 4, negative 1/2. And now, right, we have our a, we have our h, and we have our k. So now we just need to substitute it into our formula up here. So f of x is equal to a, so negative 1/2, times x minus h. Our h is positive 3, so minus 3 squared plus 4. And there's our solution. Okay, so what I'll do is I want you to try number 3 on your own, which is the next one. So I'd like you to pause it now. Okay, so hopefully you've paused it. Right, so now to solve it, right, h equals 1, k equals -4. We need to solve for a. So f of x, oh, right, our 1 is, -2 will be our x, -1 is our f of x. So we get -1 for f of x is equal to a times x, so -2 minus h, which is 1, oh, minus 4, right? Again, that was f of x equals a times x minus h squared. Oh, I missed the squared, plus k. Good thing I wrote the equation. So we get -1 equals a times -3 squared minus 4. I'm going to move the 4 over, make this, I'm going to add 4 to both sides, right? And -3, not -3, +3, equals 9, because -3 squared is 9, 9a. So a equals 1/3, right? Because you divide by 9. So now plug them into the equation, right? F of x equals a is just 1/3, x minus h, h is 1, squared plus k. Well, k is -4, so I'm just going to make it -4. And there's our solution. All right, now the last part of this section is writing quadratics that are in vertex form into standard form. Okay, so we're going to change them given some transformations, right, from vertex form to standard form. Okay, it's really not too difficult. All you need to do is figure out the transformations, subsume into this our f of x, so vertex is f of x equals a times x minus h squared plus k. And then our standard, so that's vertex form. Our standard form, you can see they wrote it here, right? Y, but we're writing functions, so we're going to use f of x equals a x squared plus bx plus c. Okay, so we want it in like an x squared plus something x plus a constant form. Okay, to do this, right, we need first step is find transformations. So our a, h, and k. This is 2 units to the right, so our h is 2. 5 units down, k is 5. Now there's nothing else, so we don't have anything for a, so our a just stays as 1 as a constant, so it's not changed at all, right? There's no reflection, no vertical stretch or compression, right? So now we're going to fill in our vertex form, right? So vertex form would be f of x is equal to a is 1, so I'm just going to leave it out, right? And then x minus h, so -2 squared plus k, plus 5 for k. Right? Now, to change this to standard form, very easy, right? All we have to do, now it says x minus 2 squared. So if you had like 5 squared, right, you change it to 5 times 5. Now we have x minus 2 squared. So we're going to change to x minus 2 times x minus 2. Right, so x minus 2 times x minus 2 plus 5. Okay, we just kind of expanded it because essentially when you square something, it's being multiplied by itself, right? So now we need to use the FOIL method and distribute these. So x times x squared. So that's x times x. X times -2 is -2x. -2 times x is -2x. And then x times or sorry, 2 times negative 2. Negative 2 times negative 2 is positive 4. Sorry, too many 2's. Last step, combine your x like terms, and then combine your constants, and we will get our solution in standard form. So we get x squared minus 4x plus 9. Now, I got this wrong. You know why? Because our k is negative 5 because it's down 5. So I'm going to fix all of these real quick. All it's going to do is change our constant, though. How do I erase that? Here we go. Okay, so this should be x minus 5. Sorry about that. So instead of plus, that's the wrong button. We should get minus 1. Okay, and there's our solution. All right, so now the next one says try on your own. I'll kind of help set you up, and then I want you to pause it, and then try it on your own, and then I'll give you the solution. And that's the last problem of this. Okay, so let's set it up real quick. We have 4 units left. Let's make sure I do this correctly. H equals negative 4. 3 units up, k equals 3. We don't have an a, so a equals 1. All right, so we get f of x equals x minus h, so it becomes x plus 4 squared plus k, which is plus 3. Okay, now expand them out. And now try and finish this off. Okay, so pause it now, and then I'll go through the solution. Okay, so hopefully you tried it on your own. All right, distribute using the FOIL method. All right, so x times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Combine our x's, combine our constants. We get x squared plus 8x plus 19. And we are done. Now, this part of the bottom of our notes, right? It's just kind of like some key concepts to remember, right? It gives you vertex form, tells you a cannot equal 0, right? Because that will just make it y equals k, right? So, right, we know vertical stretch is greater than 1, and then so is greater than 1 stretch, and then a is between, right? Not equal to, right? Between is a compression. Our axis to symmetry is x equals h because it's our x value of our vertex. Our vertex is h comma k. If a is greater than 1, it opens upward. Greater than 0, so positive. Right, it opens upward, like I said. And if it's a is negative, then it opens downward. Oh. Okay, so this will help you like for the first problems. Okay, and that's the end of the notes.